This is January 2015, this is paper 2, and this is question 7. An unstable isotope of strontium has a half-life of 28.8 years. It is a beta emitter and can be represented by the symbol below. What is the mass number of this isotope? Remembering that this one is the mass number and this one is the atomic number. The atomic number decides what type of element it is, and it's the number of protons in the nucleus. So the mass number is the number of protons and nucleons, and in that case it's 90. There are 90 protons and nucleons. How many nucleons are there? Well, that would be the number of protons and nucleons minus the number of protons. And then we get a value from that, and that would be our number of neutrons. Explain the meaning of the term half-life. Well, it's the time for the amount of radioactive isotope to half, or you could say the activity to half. This was a harder one for explain because it's more of a definition than it is an explanation. It's hard to explain the term half-life, but because that would use the word because, but in this case it's just the time for the amount or the activity of radioactive substance to half. A person can absorb strontium atoms which stay in their bones. Explain why strontium-90 in the bones is a serious health hazard. Well, one, it's going to be in your bones for an incredibly long time, almost 30 years it's going to sit inside your bones. And we know that beta radiation causes cancers, kills cells, mutates DNA, ionizes our tissues, and if it's going to do that for a very long time, then that's a very, very bad thing. Okay, so the next thing, we're going to complete the emission of the beta particle from strontium-90, and it forms yttrium-90. So we're going to complete the equation for this decay. So if it's yttrium-90, then that number should still be 90. Now, if that's 90 and this is 90, then what we have an equation for on the top is 90 equals 90 plus what? Well, it's just 0. And on the bottom we've got another equation which is 38 equals 39 plus something there as well. So what do you have to add to 39 in order to make 38? Well, you add a minus 1. And that would be the complete equation. Very easy to do. Yttrium-90 is also an unstable isotope. Explain why strontium and yttrium can both be described as isotopes, even though they have different numbers of protons. Well, it's because they have isotopes are different elements. Isotopes of different elements, has the same number of protons, same number of protons as other strontium atoms. That's going to get very muddled. Strontium atoms, but a different number of neutrons. Sorry, this is so. Check the mark scheme. They write this out much better than I will. So, explain why strontium and yttrium are both described as isotopes. It's because they're the same element as all the other strontium isotopes, because they're all called strontium. But they must have a different number of neutrons because all their masses are different. So although it has the same number of protons as other strontium atoms, it has a different number of nucleons, which changes the mass number. And isotopes are isotopes of different elements, but they have the same number of protons as all the other strontium nuclei. And that is question number 7.